Okay, well, we're back again. In our session on model selection, we've seen best subset regression, forward stepwise regression, and we've seen how to use a validation set to do model selection, as well as using the built-in CP statistic that's recorded by reg subsets. Now we're going to use cross-validation, which is one of our preferred methods for doing a model selection, and we'll use 10-fold cross-validation. And once again, we're using our R Markdown session. So we can record text and the R commands at the same time. And at the end of it all, we'll be able to produce a nice document showing what we've done. So let's look at the script and see how we do this. Okay, so there's our R Markdown code. This is a second level heading. So model selection by cross-validation, and as I said, we're going to use 10-fold cross-validation. And it's really easy, and you can write functions for doing this, but it's so easy to do that it's actually good just to know how to do it on the fly. So we'll set a random number seed, just like we did before. We'll use a different one this time. So we'll set the seed to be 11. And so here we're going to sample from the numbers 1 to 10. Each observation is going to be assigned a fold number, and they're 10 folds. So we're going to sample from the numbers 1 to 10. So we create a vector 1 to 10 of length the number of rows of hitters. Okay? So that'll try and make an equal number of 1s, equal number of 2s, up to equal number of 10s. And then we're going to basically shuffle that, and that's what the sample command does here. Okay? So we do that, and then if we look at it, there's our random assignment of folds to each of the observations in hitters. And if we tabulate that, these are just numbers between 1 and 10, you'll see it's pretty balanced. Couldn't be exactly balanced with a sample size of 263, but as close as can be. So there's either 26 or 27 in each fold. Okay, so we make now a matrix for our errors, and it's going to have 10 rows and 19 columns, because there are 19 variables, so there are going to be 19 subsets, and 10 rows for each of the 10 folds. And so now we're going to go through a double loop, and so we go for k equals 1 in 10, and now we fit a reg subsets model with cell as a response, and the training data is going to be all the observations whose fold ID is not equal to k. For this kth fold, we're going to train on all the observations but those in the kth fold. Okay? So having done that, we only need to do that once, and now we're going to go and look at each of the subsets in that trained model. So now we go through our loop for I equals 1 to 19. And now we can use our predict method that we just made. And when I say predict method, I mean it, because we wrote our predict function in a way that the generic predict understands. And so we just call predict, and the first argument is best.fit, which is a reg subsets object. And so the generic function predict knows to find the method, which was called predict.reg subsets. And now we're going to make predictions at those observations whose fold ID is equal to k. Right? So those were the guys that were left out. And we're doing it for each subset size I, which is given to our predict function by ID. Okay? So we make our predictions, and then we compute the mean squared error of the predictions and assign that into the kth row of our CV errors. And we do that for all the I and for all k. And that's done already? Well, actually it's not. Now it's done. So that was pretty quick. That was fit in 10 models. So it's not so bad, but making predictions for 19 different submodels of each. We now process our output matrix. So first of all, we use the apply function to the columns. So we take the column means, right? Because there were 10 rows, and each row was the mean squared error for a particular fold, but we want to average those, so we average down the columns. And then we use square root to get the root mean squared error. And now we can make a plot of that. And so there's our tenfold cross-validation curve. It's not quite as jumpy as the validation curve because this is averaged over the full training set. The errors are computed over the full training set, but of course done fold by fold, but then averaged. So it's a little bit smoother, and this seems to favor models of size 11 or 12.